Hello, welcome to 6.1 Simplifying Rational Functions. This is the first lesson in Unit 6, and basically we're going to be working with a lot of fraction ideas. We're going to be doing some factoring, and we're going to break down and try to simplify these fractions as much as possible. So we're going to start out with some easier ones that you've seen in the past. 2/4. We know that this can be reduced to 1/2. And the reason for that is because we have a factor of 2 in each of these. This is the same as 2 times 1 over 2 times 2. Whenever you have a common factor in the top and the bottom, you can cross those out because they would divide out from the top and the bottom, and then you're just left with the other numbers 1 and 2. So that's the reason this simplifies down to 1/2. All right, this one we got to be kind of careful here because we have 10 plus 5. We could approach this one in two different ways. We could add the 10 and the 5, which would give us 15 over 5, and we know that that's the same as 3. Or you could divide 5 into the 10 and into 5 itself. 10 divided by 5, if we look at that part first, that would be 2, plus 5 divided by 5 is 1, and we still end up with the same result of 3. So there's kind of two ways you could approach that one. But just make sure you divide the 5 into both terms on the top. This one here, we have 6x over 12. Now we're going to introduce variables into this. Don't let the variables throw you off. We're still just going to reduce the numbers first and then look at the variables. So in this case, we have 6/12, which we know we can take a 6 out of each of these. We can divide by 6, and then this would reduce to 2 on the bottom, 1 on the top. So it would end up being 1x over 2 or just x over 2. Either of these answers is acceptable. We're probably going to go for this version since it's more simplified. Okay. Here we have 30x squared over 18x to the third. I always start with the numbers like I was saying. Here we have 30 and 18. You always want to try to find the greatest common factor. In this case, 30 and 18 are both divisible by 6. So if you want to, you could rewrite this. You could rewrite it as 6 times 5 x squared, and then you could write it as 6 times 3x squared, if that helps you visualize what you're going to cross out here. Ooh, except it's x cubed. So then we can take the 6's away. Now here, notice we have x squared on top, x cubed on the bottom. If I were to expand those, if I were to write these out, we know that x squared is the same as x times x. We could think of this as a bunch of multiplication. And then here we'd have times x, and now we can just start crossing the things we have out in common. So we have x and x, and then we have 5 is the only thing left on the top, and then we have this 3 and this lone x here. The other way we could have approached that, if you don't want to take that long expanded route, is to just tell yourself, well, I know that 30 and 18 have 6 in common. Cross that out, write a 5 up above, write a 3 here, and then you know that there's 2 x's on top, there's 3 on the bottom, so then you just cross that out and you'd be left with 1x. You still end up with the same answer. However you want to approach it, you can do that. Just make sure that you're factoring and thinking about those pieces and getting down to that final answer correctly. All right, now we're going to move on to this part here. We have x minus 3 over x. This is one of the trickiest ones of all because although we can divide x into x here, don't make the mistake of trying to cross out your x's. The reason for that is, let's just give an example. Let's say that x equals 4, so you can kind of understand why we can't cross this out. If I had 4 minus 3 over 4, that is 1/4, right? We would subtract 4 minus 3. But if I were to try to jump ahead and cross these out, this would equal -3, and that doesn't make sense. So don't try to cross out your x's here, which I probably shouldn't even show you that, but I want you to avoid that mistake. In this case, because we can't take x minus 3, I'm going to backtrack here. Because we can't take x minus 3, this is already as simplified as possible. Already simplified. You can't break anything down here. We can't divide an x out. There's no common factors between the top and the bottom. Basically, we're looking for that greatest common factor. Okay, let's look at this one here. We have 2x minus 3 over x minus 3. We look at our top terms and we don't see anything we can take out of either of them. Same with x minus 3. So in this case, we're just going to write simplified. There's nothing more that we can take out of these in some instances. Now, this one here, a little bit trickier. Notice that we have a 2x minus 6. We can factor a 2 out of 2x and 6. Just like before, we would end up with x minus 3 over x minus 3. Now, because it's multiplication, it's 2 times x minus 3. That's what we were doing up above when we were looking at these multiplication pieces. We were crossing things out that they have in common that are factors. So now we can cross out an x minus 3 on both. Notice I put the parentheses around this. The parentheses around a number that doesn't need parentheses is fine. I didn't change anything, I just changed how it looked, and you'll remember to cross it out more if it's in parentheses. All right, here's our next one, x squared minus 4. This should look really familiar. You've factored this many times. That's a difference of squares, so we can factor out x plus 2 and x minus 2. Now note, again, I'm going to put the bottom parentheses, or the bottom set in parentheses to help you visualize this, but we have an x minus 2 factor on the top and the bottom, so that's why I can cross those out. And I'm left with x plus 2. And that's our answer on that one. Okay, here's some more factoring. This time I'm going to be able to factor the top and the bottom. X squared plus 5x plus 6. We know that there's factors of 6, and you can do like the cross section if you want. That would be factors of 6 that add to make 5 are 3 and 2. So in this case, it would be x plus 3 and x plus 2 over, this is a difference of squares like we just saw in the last one. So that's x plus 3 over x minus 3. We're looking for common factors, and almost always we're going to see something that we can cross out. So we can take out an x plus 3 and an x plus 3, and then we're just left with x plus 2 over x minus 3. All right, a couple more here before we're done. 6x minus 18 over 2x. Always look for the greatest common factor. We're going to see this a lot, where it's not going to be immediate what the answer should be. So on the top, we can take out a 6 from 6x and 18, and you're left with x minus 3 over 2x. Now, x isn't going to go away, but we can take 2 out of 6, and then we'd be left with 3. So then you can write this answer as 3x minus 3 over x, or you could distribute that 3 if you wanted. We would accept either answer, 3x minus 9 over x. We're probably going to leave most of our answers in this factored form, though. You're going to see that quite often because we've already practiced that. You've gone through multiplying it out, distributing. So we're going to just leave it in factored form for the sake of time. Here's one. This one, we can definitely factor the top. We know factors of 10 that add to make 7 are 5 and 2. Signs are positive, so it's x plus 5, x plus 2. Be careful, though. On the bottom of this one, it's very important to note that the 25 comes first. So that means when you're doing your parentheses, you would get 5 plus x and 5 minus x. Now, 5 plus x, addition is commutative. You can go either direction. You can say that 5 plus x and x plus 5 are the same thing because we can change the order and get the same answer. So we can for sure cross these out. But be cautious. 5 minus x is different than x minus 5. Subtraction is not commutative. You can't switch the order as easily. So our answer on this one should be x plus 2 over 5 minus x. Now note, I took the parentheses off. If you want the parentheses on there, it's fine. It doesn't matter. Okay, a couple more here. Yeah. 7x squared plus 10x minus 8. So in this case, that's a pretty intense factor. So let's try to use the box method on this one. So, before I do the box, I'm going to, 7 times negative 8 is negative 56. And then we have 10 here. So factors of negative 56 that have a difference of 10. Well, I got to think on this one here. We have 8 and 7. We would also have 4 and 14. And that would work. And it would have to be negative 4, positive 14. Okay, so then I'm going to use the box. Had to think on that one a little bit. So we would have 7x squared, negative 8, negative 4x, 14x. And then I'll factor these out. I'm going to get x, 2, 7x, and negative 4. Okay, so this factors into 7x minus 4. This factors into x plus 2. So then on the bottom, we're probably going to see something that has to do with one of those factors. This one's a lot easier to factor. We don't need the full box method here. We know factors of 30 that add to make 17 are 15 and 2. Okay, and because it's just an x squared, that's why I don't have to do the full box. So this would be x plus 15, x plus 2, and there's a good chance that we're doing this right because we notice that we have x plus 2 and x plus 2. You're probably on the right track if you're seeing at least one of the factors that they have in common. So this would be my final answer right here. Okay, so don't be scared to use the box method if you need to. It's going to happen sometimes. Right, last couple problems here. 20x squared plus 33x plus 10 over 16x squared minus 25. So again, probably going to need the box method in this case. There's nothing that I can take out of 20, 33, and 10 that they all have in common. So let me do the cross section here. So 20 times 10 is 200. So factors of 33, or factors of 200 that combine to make 33. I'm guessing it's going to be, let's see here, 40 and, nope, that's too big. 10 and 20, we would need to be in between that. Let me try, just pull the calculator here. $200 divided by, let's try 12. Nope. 200 divided by 15. Nope. 200 divided by 16. 12.5, I'm getting closer. Oh, I know what it is. Duh. 25 and 8. 25 times 8. Okay, my bad. Doing this on a Sunday night here. All right, so we'd get 25 and 8. So then we'd have 20x squared, 10 here, 25x, 8x. We'd get 5x, 2, 4x, and 5. So then this would be 5x plus 2 times 4x plus 5 over, and then this is a difference of squares because we see two perfect squares. It would be 4x minus 5 and 4x plus 5. Okay. Again, probably on the right track because we do see a common factor between the top and the bottom. So I'm going to cross those out, and then I'm going to be left with 5x plus 2 over 4x minus 5. All right, last one here. And we definitely want to practice this one because it's a cube. And notice there's 1, 2, 3, 4 terms over a difference of squares. So whenever you see 4 terms, this is probably going to be that box method immediately. This is the factor by grouping method. So you just go in order. X cubed, 5x squared, minus 9x, minus 45. Okay, so then just do the greatest common factor. We'd get x squared, negative 9, x, and 5. So then in this case, notice, I did that top part right away, and I'm glad that I did. I ended up with x squared minus 9. That can be its own factor, and then x plus 5 is another one. I could factor x squared minus 9, but I noticed that on the bottom I have the exact same thing, so I might as well save myself some time. Everything there is going to go away since it's identical, and I'm just left with x plus 5. It is okay to be left with a non-fraction answer too, where you're only having one term on the top. Or you could have it like in reverse too, where you'd have just a 1 on top and then a term on the bottom. Okay, But that is it for this one. Remember, look for the greatest common factor, simplify as much as possible, and in some instances, it's already simplified.